In this, we're going to go through how we can use experimental results to try to find the enthalpy change, so that basically the energy change in a reaction. Now, we've already seen in our last lot of experiments that if something feels hot, it's exothermic. If it feels cold, it's absorbing heat energy from us, so it's endothermic. But we want to be able to put a value to that. How many kilojoules per mole of that substance is being released or being absorbed? And that's where you'll get most of your credit in this part of the achievement standard. So one experiment that I'm going to describe to you, and I'll try to use diagrams for this, is the adding of two solutions. Alright, so we're going to have in one vessel normally something that's well insulated, so there's no heat loss or heat gain from the surroundings. Ideally we'd have a lid on it too, but it's impractical. Normally we use a polystyrene cup because it's a good insulator. Polystyrene as a substance is a good insulator. It's got very large molecules. Okay, it's a and its name suggests it's a polymer. Okay, so what we're going to have in here is we're going to put 50.0 mils of sodium hydroxide in here. Okay, now we assume with all fluids, or liquids, sorry, not fluids, all aqueous solutions, things dissolved in water, that they have the same density as water, which means this is effectively 50 grams as well. This is important in a moment. Okay. I'm going to add to that the same volume of hydrochloric acid. So 50 mils of HCl. And I'll do the concentrations in a moment. But again, this is an aqueous solution, so we can infer that this is approximately 50 grams. All right, so together we've got 100 grams of water in there with particles dissolved in them. All right, so our overall mass is going to be 100 grams. Okay. When we do this, if we use 2 moles per litre of, I'm pretty sure it's both of them, yep, 2 moles per litre, then we find that the temperature for this will actually raise by 14 degrees Celsius. Alright, so we'll find this in the book as well. So the temperature change, the big T for temperature, little t for time, big T for temperature, change in temperature is positive 14 degrees Celsius. So that means it's getting hotter, feels warm, it is exothermic. The first thing I ever do when I see these questions is I go, it's hot, I'm going to write down exothermic here as a wee note for myself. Because this means that there must be a negative enthalpy change at the end. So my final answer has to be a negative answer. Okay, so I'm going to say delta H is negative. This is just a wee note for myself to remember that my final answer has to be negative. My very final answer, my enthalpy change. Okay, so what I've got to do now is work out what's happening here. Well, water has got a specific heat capacity. That means that it can absorb or relay, or no, absorb's the right word. It can absorb a certain amount of heat energy per mil per degree Celsius. All right, and that's a nice, easy thing to do. And we give it either the symbol S or C, depending on whether you're doing chemistry or physics. It doesn't matter what the symbol is. Okay, and the specific heat capacity, which I'm going to call S, the specific heat capacity of water is 4.2 joules, not kilojoules, note. So our final answer will probably be kilojoules. Joules per gram, which is important because we've got our mass of what's changing temperature, per degree Celsius. Okay, so that's how many joules it takes to raise the temperature of 1 gram of water by 1 degree Celsius. That's what it means. All right. So you sometimes see that written as S. Okay. What we need to do is convert the values we've got, temperature change, specific heat capacity, mass. We need to convert this into an amount of energy. All right. And it's not enthalpy because it's just a temperature change. There's more to it, but it's close enough. So basically, Q, or again in physics you might use E for energy, is the mass in grams, not kilograms, okay, times the specific heat capacity, so 4.2, times the change in temperature. So our mass, our total mass of what we're working with is 100 grams, because the 250 grams together, times our 4.2 joules per gram per degree Celsius, times 14 degrees Celsius. And we get a value there of 5880. And because this is joules per gram per degree, it'll be 5880 joules. Okay. So that tells us how much energy has been released by this reaction occurring. That tells us how much energy has been released. Alright? But for enthalpy, we want to know how much for enthalpy change, we want to know how much has changed per mole. So we need to have a look at what we actually reacted there. Alright? So, for this, we need to go, doesn't matter which one, because they're both in a 1-to-1 ratio if we do the equation. So we choose either one of them, and we find out how much we have. So we use that NCV triangle that you might remember. So we still need to remember this one, where C equals N over V. We want to find the amount, the number of moles. We do have a concentration, we do have a volume. Just be careful, the volume has to be in litres when you're doing this calculation. This is the big trap for most students. They forget to turn this into litres, and so their answer is out by a factor of 1,000. So if I go 2 times 50 over 1,000, which gets that into litres, then I get 0.1 as my answer. Alright, so I'll just put that over here. I've chosen NaOH, CV 2.0 times 50 over 1,000. I do just write it as a fraction because I might as well. And I get 0.10 moles. Now, to work out my enthalpy change, I'll do this in a different colour, so this is what we're ultimately trying to do. My enthalpy change is my amount of energy, so it could be Q or E, whichever you prefer, over my amount, so that I get joules per mole or kilojoules per mole. Personally, I like to convert this into kilojoules, so I'll divide that by 1,000 to get it into kilojoules. So I end up with 5.88 kilojoules over 0.10 moles. You can see kilojoules per mole in our equations, that makes it nice and easy. So our final answer is going to be 58.8 kilojoules per mole. But wait, over here I said that it got hotter. So this won't be 58.8, it will be negative 58.8 because it's exothermic. This is the other really common mistake that students make, forgetting to put the negative sign in when it's an exothermic, and that's why I take some notes as I go and I'm doing the calculation. Alright. So basically, to summarise the steps before we finish this, you look at the mass of the thing that you're measuring the temperature of. It was the water that these things were dissolved in that you could measure the temperature of. So you get the mass of the water. Second step, determine is it exothermic or endothermic, so will your final value be positive or negative. Third step, using the specific heat capacity of water, because that's what you measure the temperature change in, work out how many joules of energy is released, and I suggest converting that into kilojoules as part of that step. Next step, what can you find the amount of? Exactly find the amount of. That's what you need to do so that you can find out how many kilojoules per mole has actually been changed in this. Right? That's your full process.